So hello future doctors, I hope you all have completed your full test 6 questions. Okay, so let's begin with the solutions of full test 6. Yeah, so let's start with the chemistry portion, section A. So in question number 51, it is said that 400 ml oxygen is obtained from a 20 ml sample of H2O2. H2O2 is hydrogen peroxide. Okay, at NTP. And what is NTP? NTP is normal temperature and pressure. The volume strength of the sample is. It is asked the volume strength of sample. So let us understand the solution. NTP stands for normal temperature and pressure, we have discussed. So now 20 ml of H2O2 gives 400 ml of oxygen at NTP. Okay, so 20 ml gives 400 ml of oxygen. Then what 1 ml H2O2 will give? 1 ml H2O2 will give 400 by 20 ml. So 400 by 20 ml, which means that 20 ml of O2 will be formed. Okay, so what will be the answer? 20 ml. That is option number 2 will be the answer. Right? Next question for question number 52. Which of the following molecule will have a zero dipole moment? So zero dipole moment we have already discussed in previous questions, right? So zero dipole moment, which of these molecules will have? Let's see. XeF2. XeF2 molecule will have the zero dipole moment. Why? Because XeF2 molecule or xenon difluoride molecule, it has a linear molecular geometry. Okay, it has a linear molecular geometry. How it has a linear molecular geometry? The central atom is the xenon and two fluorine atoms are in the linear position. Okay, so this is the linear geometry of XeO2, and also it contains 3 lone pair of electrons which are arranged like this. Okay, so the overall geometry will be linear of XeF2 molecule. Also, the direction of dipole moment we have to see now in this case. So what will be the direction of dipole moment? It will be from less electronegative to more electronegative. We know that fluorine is the most electronegative element in the periodic table. So the direction of dipole moment will be towards the more electronegative fluorine atom. Here also the direction will be towards the fluorine atom. So these two dipole movement are in opposite direction. So what it will do? It will cancel out. Therefore, this XeF2 molecule will have the zero dipole moment. Okay. So XeF2 molecule will have the zero dipole moment. Option number 4 will be the correct option. Next is question number 53. Question number 53. Identify the correct statement. Okay. Identify the correct statement. This is a compound. This is cyclohexene. Okay. Cyclohexene on reaction with KMNO4 and H2SO4 and heating gives a product X, and then again cyclohexene on reaction with KMNO4 and OH minus in the presence of water at 273 Kelvin gives a product Y. So let's read out the option. Both compound X and Y are diols. Both compound X is dicarboxylic acid and compound Y is a diol. Compound X is dicarboxylic acid and compound Y is a diol, and both compound X and compound Y are dicarboxylic acid. So let's solve for the reaction first. Okay, so now compound X obtained from the following reaction is a dicarboxylic acid. How it is a dicarboxylic acid? This is cyclohexene. Cyclohexene on reaction with KMNO4, it will form a dicarboxylic acid. How it occurs? This is due to the oxidative cleavage of the double bond. Okay, this double bond is cleaved into half, and therefore this type of cleavage is known as oxidative cleavage. Okay, so on oxidative cleavage, this type of dicarboxylic acid is formed, and this is compound X. Then again for the second reaction, this cyclohexene on reaction with these reagents, what it will give? It will form a diol. Okay, it will form a diol due to syn hydroxylation. This process is called syn dihydroxylation. Okay, syn dihydroxylation, and their compound Y is formed. So this will be the okay, X will be dicarboxylic acid. So X is dicarboxylic acid and Y is a diol. Okay, Y is a diol. So option number 3. Option 3 will be the correct option for this question. Let's move on to the next question. Question number 54. Which of the given statement is correct? Which of the given statement is correct? Okay, so first of all, just clear this thing out. The order will be like this. Okay, order will be like this. So this is an error in the question 54. So the order of covalent character is asked. Okay, so for covalent character order, what we have to do? Yeah. So the covalent character order, the order of covalent character, the order of covalent character is related to the electronegativity difference between the bonded atoms. Okay, between the bonded atoms. So here we have to see that which is the most electronegative atom. So the from AlF3, Al2O3 and Aln. Here aluminium is same in all the three cases, right? Also their oxidation state is +3 in all the three cases. Okay. So what is the difference here? Fluorine, oxygen and nitrogen. These three are the different elements. So among all these, which is the most electronegative element? So we know that the fluorine is the most electronegative element, right? So therefore the order of covalent character in this case will be same as that of the electronegative order. Okay, electronegativity order. So here the order will be AlF3, then Al2O3, then Aln. Okay. So this will be the correct option. Okay, this statement is correct. For ClO4 minus. For ClO4 minus, the bond order of ClO is asked. So for bond order of ClO, how we can find out? The structure of ClO can be, ClO4 can be drawn in this way. Cl3 oxygen and 1 here it is minus. Okay, so this type of. So for bond order, what will be the formula of bond order? The formula for bond order will be total number of bonds by total number of atoms. Okay, this will be the formula for bond order in case of ClO4 minus. So how many total number of bonds are there? 1, 2, 3, 4, 5, 6, 7. Okay, pi bond has 2 bond. Okay, and this is 1. So here it is 2, 2, 2. Or you can say number of sigma bonds we have to calculate. Okay, so there are 7 sigma bonds and how many total atoms are involved? 1, 2, 3, 4. Okay, 4 atoms are involved. So therefore, don't count the chlorine atoms. So therefore, the bond order comes out to be 1.75. Okay, so for option number 2, the bond order is 1.75 for ClO4 minus. So this is also correct. Next is the third option. Shape of SbCl5 is square pyramidal. Okay, yeah, so shape of SbCl5, its hybridization is sp3d2 and its geometry will be square pyramidal. You can see the structure here. For SbCl5, the shape and geometry will be square pyramidal. So option number 3 is also correct. So which option is correct in all the three? In this question number 54, all of these are correct. Okay, so option number 4 will be the correct option here. Okay, just focus on this, that this order is given incorrect in the question, so you have to correct it first. Okay. Next is question number 55. Which of the following species is not present under normal conditions? Okay, which of the following does not present in the normal conditions, which means that which of the following does not exist in nature at all. Okay, you can also see this question like this. or interchanging. So we know that the element whose bond order is 0. Okay, so this type of element does not exist in nature. So let's see the bond order of all these two. So for beryllium, Be2, what will be the bond order? Its bond order will be 0. So as I have discussed that the bond order 0 does not exist. So here beryllium will not exist. Be2 will not exist in nature. Okay, because its bond order is 0. You can also draw the structure like this. What is the atomic number of beryllium? It is 4, and the s orbital, its atomic orbital, or you can say its electronic configuration is 1s2 2s2. Okay, so for 2s we have to draw the atomic orbitals like this. This is for beryllium, this is for beryllium, this is sigma 2s orbital, and this is sigma star 2s orbital. So for beryllium there are 2 electrons, and for this beryllium also there are 2 electrons. So how many total electrons are there? Okay, and the bond order, what is the formula of bond order? It's half by number of bonding electrons by number of anti-bonding electrons. Okay, so there are number of bonding electrons, that is 2, and number of anti-bonding electrons also is 2, which comes out to be 0. So its bond order comes out to be 0, right? So beryllium does not exist in nature. Okay, next is question number 56. In question number 56, the molality of the solution in its aqueous solution is 5.55. Okay, molality, that is small m is given as 5.55. Then the mole fraction of the solute will be, you have to find out the mole fraction of solute. So what will be the formula for mole fraction of solute? Is its m equals to molality equals to xb by 1 minus xb. What is xb? It is the mole fraction of component B. Okay, mole fraction of component B. So here from this equation we can calculate the mole fraction of solute, right? So for molality it is 5.55, and on calculating this, on putting the values in this equation, we get the xb is equals to 1.11. 1 by 11. 1 by 11, okay, which will be the correct option. Option 3 will be the correct option for this question. For question number 57. Question number 57 says that which molecule has a bond angle of, which of the molecule has bond angle of 180 degree. So 180 degree, we can draw the structure of all of these. Okay, or else for first one only we can draw, like for CO2 molecule it is a linear shape molecule. Okay, and linear shape molecule means its bond angle is 180 degree. So its bond angle is 180 degree. This is only asked in the question, right? Which molecule has a bond angle of 180 degree? So CO2 has a bond angle of 180 degree. Okay. Question number 58. Question number 58 says the ionization enthalpy of hydrogen atom is 1.312 into 10 to the power 6 joule per mole. The energy required to excite the electrons in the atom from n equals to 1 to n equals to 2. Okay. So here we have to find out the energy. Energy is asked. So what is the formula for energy in hydrogen atom? So the ionization of hydrogen atom is the energy absorbed when the electron is in the first cell. First cell means E1 to infinity, E infinity. Okay. So for energy we can use this equation, E is equals to E infinity minus E1. Energy is ionization enthalpy is given as 1.312 into 10 to the power 6, and E infinity is 0, and E1 we have to calculate. E1 is asked in the question. So on equating this, what will be E1? E1 will be, comes out to be this, and on solving, okay, E1 comes out to be this. Now the energy required when an electron makes a transition from N1 to N2. So we have to look upon the transition also. So required energy will be E2 minus E1, and E2 we have calculated as 1 minus 1.312 into 10 to the power 6 by 2 to the power square. Okay, and E1 also we know. So on calculating this, the answer comes out to be 9.84 into 10 to the power 5 joule per mole. Okay. So 9.84. Okay. Option number 4 will be the correct option. Next is question number 59. Isoelectronic molecules or ions have. What does isoelectronic molecules or ions have in common? They have same number of electrons, they have same bond order, or they have both, or they have none. Okay, so we know that the isoelectronic molecules are those molecules which have the same number of electrons and the same bond order as well. Okay, so option number 1, they have same number of electrons and same bond order, which due to which the correct option will be option number 3, which is both 1 and 2. Okay, clear? Question number 60. Question number 60 says the decreasing order of acidity of the following phenols. Decreasing order of acidity is asking, okay? Which means that the one which is the most acidic will be in the first, will be at first. Okay, so let's see. All of this upper part is same in all the cases. We have to differentiate between these. So here we can see that, okay, first of all, we should write it down like acidity is directly proportional to electron withdrawing group and it's inversely proportional to electron donating group. Okay, which means that if electron withdrawing groups are present, the acidity will be greater, and if electron donating group are present, the acidity will be lesser. Okay, it will be less acidic. So let's see which is electron withdrawing group and which is electron donating group, and also we have to focus on the order of electron withdrawing and electron donating group. Okay, so for Cl is the electron withdrawing group. We know that CH3 is the electron donating group, NO2 is the electron withdrawing group, and OCH3 is also electron withdrawing group, right? So let's focus on the order first. Okay, OCH3 is electron donating group. Okay, it is electron donating group. So let's focus on the order. Electron withdrawing group, this 1 and 3. These both are electron withdrawing group, which means that one of these will be most acidic. So on considering the order of acidity now, or you can say order of electron withdrawing group. So when we consider the order of electron withdrawing group, the nitro group is more electron withdrawing in nature than the Cl group. So nitro group is more acidic. So option number 3 will be at first. In all these options, option number 3. Here it is option number 3 which is at first. So option 3 will be the correct option automatically. But let's see the other options as well. Okay. So option numbers, then chlorine. Chlorine 1 will be second most acidic group. So option 1, second most acidic group. Then after option number 2, this electron donating and this electron donating. So least electron donating among these two is CH3 So option 2 will be the third most acidic, and the last least acidic will be OCH3 Okay, option number 3 will be the correct option in this case, right? Okay. Next is question number 61. Yeah, so for question number 61, the correct order of acidic strength of oxyacid is. Correct order of acidic strength of oxyacid. So we have to find out the correct order of acidic strength. Okay. So let's see. The acidic strength of oxyacid has the increases with the increasing oxidation state of halogens. So among all this, which halogen have the highest oxidation state, then that will be most acidic in nature. Okay, so let's find out the oxidation state of the halogens first. So in HClO4, the chlorine atom has the oxidation state of +7. In HClO3, the chlorine atom has an oxidation state of +5. In HClO2, the chlorine atom has an oxidation state of +3. and in HClO, the chlorine atom has an oxidation state of +1. So among all these, which has the highest oxidation number, HClO4 has the highest oxidation number, which means that it is the strongest acid. Okay, so this will be the only order of the acidic strength, okay, of oxyacids. So HClO4 is in the highest, then HClO3, then HClO2, and then HClO. Option number 3 will be the correct option. Okay, next is question number 62. What transition in the hydrogen spectrum would have the same wavelength as the Balmer transition n equals to 4 to n equals to 2 in the He plus spectrum, helium plus spectrum. Okay, so what we have to do, we have to compare the wavelength of the transition in hydrogen spectrum with the Balmer transition. We have to compare the wavelength of transition in the hydrogen spectrum with the Balmer transition. Okay, so first we will look upon the hydrogen transition. So for hydrogen spectrum, 1 by lambda equals to Rz square, 1 by N1 square minus 1 by N2 square, right? So N1 here is 2 and N2 here is 4. We have to consider the Balmer spectrum. So here lambda we will get as 4 by 3 pi upon solving this. So according to the question, the desired transition of hydrogen will have the same wavelength as that of helium plus. So for that, what we can do, Z here comes out to be 1 for hydrogen, and then lambda we will get as 3 by 4. Okay. So by hit and trial method, the equality given by equation 1 is only 2. When we put on this equation, so this will be only true when N1 is equals to 1 and N2 equals to 2. Okay. So in this case, what we can say that the transition for N2 is equals to 2 and to N1 equals to 1, which means that N2 value comes out to be 2 and N1 value comes out to be 1 in this case, right? So the hydrogen spectrum would have the same wavelength as the Balmer transition. The transition for N2 is equals to 2 and N1 equals to 1. So correct option here will be option number 4. N2. Here N2 is equals to 2 and N1 equals to 1. Okay. For question number 63, which of the following reactants will give the products ARH plus N2 plus H3PO3 plus HX? Okay. So which of the following will give the product? Here, this what is the name of this compound? It can also be drawn as this compound is known as benzene diazonium chloride. Okay, benzene diazonium chloride. So this type of compound you can say that एक होता है ना बचपन में लाइक कि आपका जब आप ऑर्गेनिक केमिस्ट्री पढ़ रहे हो स्टार्टिंग में जब 11th में स्टार्ट किए हो and you are fascinated by all the structures here. So I can say that this structure was the most fascinating structure. I don't know what was the reason, but I like to draw this structure. So you can say that this structure is the most fascinating structure for me when I first started to learn the aromatic compounds, structure of aromatic compounds. Okay, so this is the benzene diazonium chloride. So benzene diazonium chloride when reacted with H3PO2 and water, it will give benzene plus N2 plus H3PO3 plus HCl. Okay, so this only we have to form as the product, and what will be the reactant? It will be aromatic N2X plus H3PO2, okay, and H2O. So option number 3. Option number 3 will be the correct option. Next is question number 64. Atomic and ionic radii of group 16 elements decreases from top to bottom. Okay, so atomic and ionic radii of group 16 element decreases from top to bottom. Second question, let's read the second statement also. Ionization enthalpy decreases down the group 16. Oxygen has less negative electron gain enthalpy than sulfur, and we have to find out the correct statement. Okay, which of these is the correct statement? So let's read the answer. The element of group 16 have 6 electrons in the outermost shell and have an electronic configuration this. So due to the increase, when we increase the number of cells, the atomic and ionic radii, what will be the trend? It will increase from top to bottom. So top to bottom it will increase. On going from top to bottom, the ionic radii will be increased. However, the size of oxygen atom is exceptionally small. Ionization enthalpy decreases down the group. Okay, so ionization enthalpy decreases down the 16 group. So yeah, second one is true. Ionization enthalpy decreases down the group 16. Second one, let's read the first statement also. Atomic and ionic radii of group 16 elements decreases from top to bottom. Okay. It decreases due to increase in the number of shells. Due to increase in the number of shells, if the number of shells increases, the atomic and ionic radii will increases from top to bottom. Okay, but here it is given it is decreases. So option number 1 will be the incorrect one. Next is it is due to the increase in size. Okay, however the elements of group have lower ionization enthalpy values as compared to those of group 15 in the corresponding period. Lower ionization enthalpy, which means that oxygen and has less negative electron gain enthalpy than sulfur. This is due to the fact that group 15 elements have extra stable half-filled p orbital configuration. Okay. So, yeah, they have lower ionization enthalpy. So, oxygen has less electron gain enthalpy. Yeah, this is also correct. So, option number 2 and 3 are correct. So, which will be the correct option? Option 3. Both 2 and 3 are correct. Option number 1 is incorrect. Statement 1 is incorrect, you can say. Okay. Next is question number 65. For question number 65, after a series of successive distillations, the remaining liquid in the distillation flask gets enriched in the dash component. Okay, gets enriched in the dash component. So, after a series of successive distillations, the remaining liquid in the distillation flask gets enriched in the high boiling component. So, high boiling component will be the correct option. Option number 1, high boiling component. Okay. Question number 66. A 0.66 kg ball is moving at a speed of 100 meter per second. The associated wavelength will be, what will be the wavelength? Value of Planck's constant is given as 6.66 into 10 to the power minus 34 joule per second. Okay, joule second. So we have to find out by using the common equation, lambda is equals to h by mv. Here we know that h is the Planck's constant and its value is also given 6.66 into 10 to the power minus 34 joule second. So on putting this, we will get the lambda value as 1.0 into 10 to the power minus 35 meter. Okay, option number 2, 1.0 into 10 to the power minus 35 meter is the correct answer. Question number 67. The stability of +1 oxidation state among aluminium, gallium, indium and thallium increases in the sequence. The stability of +1 oxidation state we have to calculate. Okay, we have to see the stability of +1 oxidation state among all these. So the stability of +1 oxidation state among aluminium, gallium, indium and thallium increases in the sequence. So this is the sequence of oxidation state. Why it is there? Because of the inert pair effect, due to which you are moving down the group. As we move down the group, the stability of +3 oxidation state decreases while the stability of +1 oxidation state increases. Okay, so here aluminium, then gallium, then indium, then thallium is there. So when we move down the group, the oxidation +1 oxidation state ability increases, okay, and +3 oxidation state ability decreases. So here what is asked, the stability of +1 oxidation state. So the compound which is at the bottom will have the greatest +1 oxidation state. So aluminium will have the lowest, then gallium, then indium, then thallium. Option number 2. Option 2 is the correct answer, right? Yeah. Question number 68. What does question number 68 show? Which of the following compounds will show the geometrical isomerism? So we know that for geometrical isomerism, the group should be attached to a different carbon, different side. Okay, groups have to be attached to the carbon and should be at different side. So these are the options. So we can draw for every option. Okay, where is the space? Here we can draw. So first one is C double bond C, and here it is H, and here it is CH3. Here it is C2H5, and here also it is C2H5. So these two groups are the same. These two groups are the same, then it will not show the geometrical isomerism. Okay, it means that the carbon should have different groups. Each carbon should have different groups for a compound to show geometrical isomerism. Okay. Next is C double bond C. Here it is Cl, here it is Cl, here it is H, and here it is H. So in this case, these two are also same and these two are also same. So it will also not show the geometrical isomerism. Third option. Here it is C6H5, and here it is H. Here it is H, and here it is CH3. Okay. So here all these two are also different and these two are also different. So yes, option 3. Option 3 will show the geometrical isomerism. And let's see the option 4 also. C, here it is Br, here it is Br, here it is Cl, and here it is Cl. Okay. So these both are also same, so it will also not show. So which is the correct option? Option 3 will be the correct option. Option 3 will show the geometrical isomerism. Clear? Question number 69. So for question number 69, due to stable electronic configuration of noble gases, these gases exhibit very high emission enthalpy. This is correct statement. These have no tendency to accept the electron. This is also correct. And they have large positive values of electron gain enthalpy. Okay. So this is also correct. Which means that what is asked in the question? The incorrect set of statements. So these three are correct. So none of it is incorrect. So which will be the correct option? Option 4. None of these is the incorrect statement. Question number 70. Question number 70 says that if the heat of combustion of CH4, if the heat of combustion of CH4 to CO2 and H2O is 400 kilojoule per mole, the heat released upon the formation of 32 gram of CO2 from CH4 to O2 will be nearly. So it is asked the heat release. We have to find the heat release. So let us first try to solve this question. Okay. Yeah. So question number 70, the heat of combustion. So let us first write down the equation. Heat of combustion, which means CH4, it is reacted with 2O2 to give CO2 and 2H2O. Okay. So here the heat of combustion of CH4 is given in the question. Here it is given how much? 400 kilojoule. 400 kilojoule per mole it is given. Right. So now we have to find out the heat released upon the formation of 32 gram of CO2. So for 32 gram of CO2, it is delta combination of delta H of combination heat of combustion by molar mass of CO2 into how much we have to found? 32 gram of CO2 is released. So into 32, it comes out to be 291 kilojoule. Comes out to be 291 kilojoule, which is option number 3. Right? Question number 71. Which reaction produces alkynide when sodium is reacted with liquid ammonia? Okay, which of the reaction produce alkynide when the sodium is reacted with liquid ammonia? So let us see. Alkynide is formed. Okay, so among all this, I am solving for the correct option only. You can solve for all of these. Okay, so here what happens? Sodium is reacted with liquid ammonia. Okay, it is liquid ammonia. What will be the product which is formed? This type of product is formed. Okay, this type of product is formed, and this is called trans, or you can say E-alkene, and this is only the name for alkynide. Okay, this is the alkynide. So which is the correct option? Option number 1. Option number 3. Option number 3 reacts to form alkyne. Okay. Question number 72. Which of the following species will have the largest size? Which have the largest size? Question number 72. Okay, so here the chart, okay, for larger size cations, okay, these Mg plus 1 is the cation of Mg and Al plus 3 is the cation of Al. So the cations, the cations always have smaller size than the parent atom. Okay, smaller size than the parent atom. So here for Mg plus 2 cation, their parent atom is Mg, and for Al plus 3, the parent atom is Al. So these two will not have the largest size. So we have to compare upon Mg and Al. Okay. So Mg, size of the element, we know that it decreases from left to right. So if it decreases from left to right, so magnesium is at the left side, so it will have the largest size. So magnesium will have the largest size among all. Clear? For question number 73, when primary amine reacts with ketone, what is the expected product? Okay, so primary amine, let us see the reaction. RNH2, it is the primary amine, or you can say 1 degree amine. So when it is react with ketone, it is ketone, it will give imine as the product and water as a byproduct. So imine is formed, okay, and imine is formed in the Schiff's base. Schiff's base are characterized by it is also called Schiff's base. Schiff's base are characterized by the presence of an imine, right? Imine functional group is present, so the answer will be Schiff's base. Question number 74. 100 ml of 0.1 molar HCl is neutralized by 50 ml of 0.2 molar NaOH. The solution, NaOH solution at 25 degrees Celsius. The temperature of the final solution is increased by specific heat capacity is given of water as 4.2 joule per Kelvin per gram. Assume that the density of final solution equals to density of water and mass of final solution equals to mass of water. Okay, this is the assumption that we are given with. And what else is given in the question? The specific heat capacity is given. Specific heat capacity of water is given, and 100 ml of 0.1 molar HCl is neutralized by 50 ml of 0.2 molar HCl. So volume and molarity is given of the of acid and base. Temperature of the final solution. The temperature we have to find out. We have to find out the temperature. Okay, so let's start solving this. So this is the neutralization reaction. We know HCl plus NaOH will give NaCl plus H2O. So we have to calculate the millimoles of HCl and O2. So what will be the formula? The millimoles is equals to volume into concentration. Okay, so volume. Let's calculate the millimoles of HCl. So for millimoles of HCl, the volume of HCl is given as 100 and concentration is given as 0.1 molar. So what it will come? It will come as 10 milliliter, right? Or it is 10 millimoles. 10 millimoles. Now for millimoles of NaOH, similarly we can calculate for NaOH what is the volume. The volume here is the volume given as 50, right? 50 ml into 0.2 molar. So it comes out to be also 10 millimoles. So for HCl it is 10 millimoles and for NaOH it is 10 millimoles. Okay, so no limiting reagent is present in this case. These both reactions will go on independently, right? So no excess reaction, no excess reagent is left, we can say. Now we can use the formula Q is equals to Ms delta T. Okay, where what is Q is the heat released, M is the mass of solution, S is the heat capacity, and delta T we know that it is the temperature difference. Okay, so now let's see, it is given in the question that the density of final solution equals to density of water and the mass of final solution equals to mass of water, right? So mass of solution equals to mass of water, it is given. So what will be the mass of solution in that case? Mass of solution will be 150 gram. Okay, it is given in the question. So energy released is absorbed by water, which is equal to 150 ml or say 150 gram, and the density of water we know that it is 1 gram per ml. So on putting this value in this equation, we get Q is equals to ms delta T, and delta T comes out to be 0.9 Kelvin. Okay, so 0.9 Kelvin will be the answer to this question. I hope you have understood this question. Okay, let's move on to the next question. Question number 75 says, find out the value of Kc for the following equilibria from the value of Kp. This is the equation we are given with, and Kp value is given at 500 Kelvin. So Kc is equals to Kp by RT delta Ng. This is the formula for which shows the relation between Kp and Kc. Okay. Delta Ng we know that from the equation, number of moles what we will get, delta Ng equals to number of moles in the product, it is 3, and number of moles in the reactant, it is 2. Okay, so what will be delta Ng? It will be 1 for the reaction. So on putting this value in the given equation, we get Kc as 4.38 into 10 to the power minus 4 Kelvin. Okay, 4.4 molar. So which is the correct answer? Option 3. Option 3 will be the correct answer for this case. Next is question number 76. What is the correct order of electron affinity? We have to calculate the correct order of electron affinity. So electron affinity, what is electron affinity? It is the energy released when a neutral atom in the gas phase gains an electron to form a negatively charged ion. Okay, which means that a neutral atom, let us consider there is a neutral atom, and it does, it gains an electron and becomes a negatively charged electron, negatively charged ion. It is the measure of how much an atom likes to gain an electron. Okay, electron gain enthalpy is the measure of how much electrons it will gain, how much electron an atom will gain. And a higher electron affinity indicates the attraction for additional electron. Like say if you like mangoes, like, right, क्योंकि अभी समर का सीजन आ रहा है, so most of us are in love with eating mangoes, right? So your affinity, or you can say your affinity or your attraction towards mango is considered, like whether you like mango so much that you can eat 10 to 15 of it, or you does not like mango and you can eat only 1 to 2 of it. Okay, or you does not at all like mangoes, you will not eat. So this is the following case. So in all these we have mentioned with the electronic configuration. So here option 3, Cl has the highest electron affinity value and 1 fluorine has the second highest. Okay, so here from this electronic configuration we can find out the element name. So 3 is chlorine, 1 is fluorine, next is second is nitrogen, and fourth one, what is fourth one? It is helium, 3s2 3p6, 1s2 2s2 2p6 3s2 3p6. Okay, which means that 6 7 10 16 17 18 it is neon. Okay, so among all this, which has the highest electron affinity value? Chlorine has the highest, which means option 3 is the highest electron affinity value. So option 2 will be the correct option. Then fluorine will have, and then nitrogen. Okay, nitrogen will have the negative electron affinity value. Nitrogen will have the negative value of electron affinity. So neon will have more electron affinity value than nitrogen. Question number 77. Which of the following is the weakest base? Which of the following is the weakest base among the following? So the more stable the carbon ion will be least reactive towards the proton and thus will be the weak base. Stability of carbocation. So let us say stability of carbon ion. Okay. Stability of carbon ion. More the stability of carbon ion, it will be least reactive towards proton. Least reactive towards proton. And it will act as a weak base. So for a weak base, you have to find out which is the most stable carbon ion. Okay. So the most stable carbon ion is this one in this case, which is option number 2. Option number 2. This is the most stable carbon ion as well as it is the most weakest base. Okay. Question number 78. This and this are. What is the relation between these two? These are linkage isomerism. Okay, these are linkage isomerism. How they are linkage isomerism? Linkage isomerism are two coordination compound in which the donor atom of at least one of the ligands is different. Donor atom of one of the ligand is different. Okay, this is the donor atom and these are different in this case. So the type of isomerism exists is linkage isomerism. So we can say that the relation between these two is linkage isomerism. So next question is identify the major product P. Identify the major product P. So what is the major product in this case? So it is tertiary or this is the tertiary carb. You can say this is quaternary. This is quaternary. And it reacts with alcoholic KOH and heated. Then what will be the reaction? This will be the product. This will be the final product. Option number 1 will be the final product. What is happening here? Elimination reaction is happening. Or you can say even mechanism is followed because a bulky tertiary butyl group. Yeah, this is tertiary only. Tertiary butyl group is present after the formation of carbocation. Methyl shift occurs. Okay, methyl shift occurs, which means that this methyl is shifted here and the chlorine molecule is removed. So this is the final product. Option number 1 is the final product. Next is question number 80. The solubility product of ZnO2 ZnOH whole 2 is 4 into 10 to the power minus 15. Then the concentration of OH minus in the saturated solution of ZnOH whole 2 will be. The solubility product of ZnOH whole 2. Solubility product of is given, which means that Ksp is given. Okay, Ksp is given and this is the equation we can form here. ZnOH whole 2 solid reversible Zn plus 2 aqueous plus 2 OH minus aqueous. Zn plus 2 aqueous, it has S and 2 molecules of OH is formed, it is 2S. So what is the solubility product? It is 4S3 and solubility product is given in the question. Then S comes out to be 10 to the power minus 5. So the concentration of Zn plus 2 is 10 to the power minus 5 mole liter inverse. Okay, 10 to the power minus 5 mole liter inverse. Option number 3. Okay. Yeah, also, okay, we have calculated for this part only, na? Since each mole of ZnO2 produces 2 moles, so okay, don't forget this part, okay? Don't forget this part, otherwise you will do the answer wrong. Since each mole of ZnO2 produce 2 mole of OH, okay? So the concentration will be twice, therefore 2 is added here. 2 into 10 to the power minus 5 mole liter inverse. This is the solubility product, or you can say this is the concentration of OH. Okay, option number 3. Next is question number 81, which is paramagnetic among the given complexes. So for a compound to be, for a complex to be paramagnetic, its oxidation state should be 0. Its oxidation state, okay, no, for VCO3, its oxidation state is 0. Okay, so due to the presence of unpaired electron, no electrons are there, then obviously it is unpaired, so it is paramagnetic in nature, and option number 4 is paramagnetic. You can calculate for all these three also accordingly. Okay. Next is question number 82. Which of the following is not expected for the given reaction? Which of the following is not expected for the given reaction? Okay, so this is the reactant. When on hydrolysis, what will happen? The OH is removed from here and a positive charge is developed. Then again what happens? Ring expansion is there. Ring expansion, the ring is expanded and a 6 carbon compound is formed. Then again what happens? This OH undergoes tautomerism and this is the product we obtain. Also the second case is also possible when this OH is removed from here, okay, and here a positive charge is generated, which is again CH3 is shifted, the CH3 group here is shifted towards this side and this is the compound we will form. This compound is formed, okay. So it is asked in the question that which of the following is not expected. Which is not expected. So this is not expected and option number 3. Option 3. This is not expected. Okay. Option both 1 and 3 is not expected. So option number 4 will be the correct option. Question number 83. The solubility product of AlOH whole 3 is 2.7 into 10 to the power minus 11. The solubility of AlOH whole 3 is. So the solubility product is given as 2.7 into 10 to the power minus 11. Okay. What will be the solubility of AlOH whole 3? So for this we have to write the equation AlOH whole 3 reversible Al plus 3 aqueous plus 3 OH minus A aqueous. Okay. So for Al plus 3 there is S and for 3 OH there is 3S. So KSP we know that concentration of both of the products. So on calculating this, X comes out to be 10 to the power minus 3. Option number 2 is the correct option for this. Okay. Next is question number 84. Question number 84 says the crystal field. Okay, where is the pen? Yeah. The crystal field splitting energy for NiCl whole 4 minus 2 will be. Crystal field splitting energy for NiCl whole 4. It has the sp3 hybridization. So hybridization of Ni plus 2 will have the electronic configuration of 3d8 and 4s0. So we know that Cl is a weak field ligand, so pairing does not take place and it is a tetrahedral geometry. sp3, which means that it is a tetrahedral geometry, right? And the Cl is weak field ligand, so pairing does not take place. So for crystal field splitting energy, we will use the formula of tetrahedral one. It will be minus 0.6 into 4 delta T plus 0.4 into 4 delta T. Okay, so it comes out to be minus 0.8 delta T. Minus 0.8 delta T, option number 3 is the correct option here. Next is question number 85. Question number 85 says the order of reactivity for the following reaction. So order of reactivity, this is the equation and we have to find out the reactivity of halogen. Whether X will be chlorine, bromine or iodine. Chlorine, bromine or iodine. Okay. So we have to find out the reactivity order of the halogens. So for halogens, the reactivity increases as the nucleophilicity of the halide ion increases. So on considering the nucleophilicity order, the iodine will be more nucleophilic in nature, then bromine and then chlorine. Okay. So this will be the only answer for the reactivity also. So Hi will be most reactive, then Br and then Cl. Option number 3 will be the correct option here. Okay. Next is section B. So let's come to section B. For section B, question number 86, which of the below mentioned amines is produced in the human body? It is the question of biomolecules. So which is formed in the human body? Let's see the option: alanine, lysine, valine and histidine. So we know that alanine, aspartic acid, asparagine and glutamic acid, serine can be synthesized by human body. So these 5 are the ones which are synthesized by human body. So in the options, alanine is the only one which is synthesized or produced in the human body. Okay. Now question number 87. Question number 87 says how much amount of CuSO4.5H2O required for liberation of 2.54 gram I2 when titrated with Ki in 4.99 gram. Okay. How much amount of copper sulfate pentahydrate required for liberation of 2.54 gram I2 when titrated with Ki. So we have to write the balance equation for this. So 2 CuSO4 plus 4 Ki will give I2 plus Cu2 I2 plus K2SO4. Okay. According to the balance equation, we know that 2 moles of H2 CuSO4 produces 1 mole of I2. 1 mole of I2 is produced. So given moles of I2 we can calculate by mass by molar mass, and mass here is 2.54. Molar mass is also 254, which comes out to be 0.01 moles. Now 1 mole of I2 is produced by 2 moles of CuSO4. So 0.01 mole of I2 will be produced by 2 into 0.01 moles of I2. It is simply unitary method. Okay. By unitary method only we are calculating, which means that 0.02 moles of CuSO4 is produced. Now we are what we have to calculate? We have to calculate the amount which means the molar mass. So which means the mass. So molar mass of CuSO4 to 5H2 we can calculate as 249.5 gram per mole, and mass comes out to be number of moles into molar mass, which is 4.99 gram. Okay, 4.99 gram, which is option number 2. Option number 2 will be the correct one. Question number 88. Question number 88 says a purple colored solution is made alkaline with KOH and treated with Ki, forming potassium iodide. This solution is then acidified with H2SO4 and again is treated with Ki, but this time instead of potassium iodide, iodine gas is radiated. This purple color of the solution is due to. So we have to find out the purple color solution, which is the starting product here. So I am writing the equation. You can find out from there that which is the purple color solution. Okay. So KMNO4 plus KOH. Okay. It will give K2MnO4. K2MnO4 is produced, then it is again treated with Ki. It is again treated with Ki and formed K. I am writing here only. K2MnO4, and it is again treated with Ki to form KiO3. Okay. The solution is acidified with H2SO4. The solution, this solution K2MnO4. So K2MnO4 is again acidified with H2SO4, and the reaction will be, the product will be K2SO4 dot I2. I2 is released. Okay. So the purple colored solution here is this one, KMNO4. KMNO4 potassium permanganate. Option number 3 will be the correct option. Okay. This is the practical type question you can solve. Next is question number 89. For question number 89, identify the compound formed when benzaldehyde and acetaldehyde are heated in alkaline medium. So let's see the reaction. Benzaldehyde, right? So for benzyl, this is the benzaldehyde, acetaldehyde. It is treated with a base with the alkaline medium, say dilute NaOH. So what will be the product here? The product will be formed as a cross aldol product. Okay. And here one more benzene is there. So this type of product is formed. So this is the product, and what will be the correct option? Option number 2 is the correct option. Okay, sorry, option 1. Option 1 is the correct option. Okay, but here it should be like this CHO, and here it will be 1 pH more. Okay, option number 1 is the correct option. And which is the reaction taking place here? Cross aldol condensation reaction is taking place here. Okay. Next is question number 90. Question number 90 says that it is given in the question Cr plus 2 will give Cr plus 3 plus E minus, and its E naught value is given as 0.41 volt. Then again second equation is given and its E naught value is also given as 1.80 volt. Then E naught for the following half cell. This half cell is given and we have to find out the E naught value for this. Okay. So now we know that for first equation delta G1 equals to minus F of 0. So this formula, what is this formula? This formula is delta G naught is equals to minus F E naught. Okay. This formula we know that for Gibbs free equation. So for delta G1, it comes out to be minus F into 0.41. N is 1 here. For second question, this is the second equation we will get. And for third, for finding the third equation, delta G0 equals to delta G2 minus 2 delta G1. Okay. And on putting this value, we will get delta E0 equals to 1.39 volt. 1.39 volt, option number 3. You just have to solve this, okay? Question number 91. In the context of lanthanoid, which is the following is which of the following is not correct? Not correct. Okay. There is a gradual decrease in the radius of the members with increasing atomic number in the series. All the members exhibit +3 oxidation state. Because of similar properties, the separation of lanthanoid is not easy. Availability of 4f electrons results in the formation of compounds in +4 oxidation state for all members of the series. Okay, let's find out the incorrect one. So first one is a gradual decrease in the radius of lanthanoid with increasing atomic number in case of lanthanoid contraction. Yeah, first one is possible in case of lanthanoid contraction. This statement is true. For second statement, ionization potential for the formation of Lu +3 is comparatively low, hence +3 oxidation state is favorable. Yeah, so +3 oxidation state is favorable. This is also true. Third one is due to lanthanoid contraction, zirconium, HF, Nb, Ta, Mo, W have the same size and similar properties, thus the separation is not easy. Why? Because of lanthanoid contraction. Option number 3 is also correct. And option number 4, formation of +4 states requires very high energy. So here it is given that availability of 4 will result in the formation of +4 oxidation state for all members. So this is not possible. Very high energy is required. So therefore option number 4 is the incorrect option. Okay. Question number 92, EMF of the cell. We have to find out the EMF of the cell. Simply an equation is given. E naught value is also given for reduction and oxidation potential. So E naught cell will be calculated as 0.5 volt. 0.5 volt is the correct option. Okay. Question number 93. Question number 93 says that in this reaction is given A, B and C. We have to find out the product C. So acetic acid on reaction with lithium aluminum hydride, reduction happens and here we can get as alcohol. Then again PCl5 is added. We will get haloalkane, and then alcoholic KOH is added and we will get alkene as the product. Okay. So alkene, which means ethylene as the product we will get. Okay. Next is question number 94. Which of the following is the correct set of reactant for Raman-Taymer reaction? So for Raman-Taymer reaction, which is the correct reagent? C6H5OH. Yeah, C6H5OH, it is phenol. Phenol is required. Then chloroform. CHCl3, chloroform is also required. And then NaOH. NaOH is a base. Base is also required for a Raman-Taymer reaction. Okay, here it is CHO is formed. So option number 1 only is correct because phenol and chloroform and base is required for a Raman-Taymer reaction to take place. Okay. What is the name of this compound? It is salicylaldehyde. Next is question number 95. The decomposition of a substance follows first order kinetics. The concentration is reduced to 1/8 of its initial value in 24 minutes. The rate of constant for the decomposition processes. We have to find out the rate constant. K we have to find out, and for finding out K, which formula we can use? K is equals to 2.303 by T log of A naught by AT. A naught is here A and AT is the A. We can write like this also. Okay, so value of K comes out to be this, which means option 3. Option 3 will be the correct option here. Question number 96. Okay, these questions are repeated once or twice because these are the important type questions. Okay, these you can find out in most of the previous year questions as well. For the first order reaction, the value of the rate constant reaction is A gaseous tends to 3B gaseous plus C gaseous. If P naught is the initial pressure and Pt is the pressure of the reaction mixture at time t. For first order value of rate constant, you have to find out the value of rate constant K, you have to find out. So for this reaction at T is equals to 0, A is equals to P naught and B and C are 0. At T is equals to T, A tends to be P naught minus P and B is 3P and C is P. So for on finding the total pressure, we will get P naught plus 3P. So P here we can write as PT by P naught by 3. So on putting this value at KT, we can find out KT is like this. KT, we will find out K is equals to this. Okay, KT, or you can say like this, KT. We can find out the value of this as 2.303 by T log of 3P4, 3P naught by 4P naught minus PT. Okay, option number C. Option number C is the correct option. Next is question number 97. In Zelda's method of estimated in an organic compound, nitrogen is... Okay. In Zelda's method of estimation of nitrogen in an organic compound, nitrogen is first converted into... So nitrogen is first converted into ammonium sulfate. Okay, ammonium sulfate it is converted. So ammonium sulfate will be the correct option. These are the theory based questions. You have to remember all this. Okay. Question number 98. Next is question number 98. A metal M readily forms water-soluble sulfate MSO4, water-soluble hydroxide MOH2 and oxide MO, which becomes inert on heating. The hydroxide is soluble in NaOH, the M is. So here BeSO4 is water-soluble but BOH2 is water insoluble. Because of amphoteric nature, what happens that BeOH2 dissolve in NaOH forming a soluble sodium berylate. Okay. So soluble sodium berylate. So which is the reaction here? Which is the component here? It is beryllium. So beryllium readily forms water soluble sulfate and water insoluble sulfate as well. Okay. Question number 99. 5 liters of gas is heated from 27 degree to 227 degree at a constant temperature. Then the final volume of the gas. So for final volume of the gas is asked. So this is the most common formula. V1 V2 is equals to T1 T2 or V2 V1 equals to T2 T1. Okay. So this is here is T1 and it is T2. Final volume we have to calculate. V2 is not given and V1 is 5 liter. Okay. So on calculating this, V2 comes out to be 8.33 liter. 8.33 liter. Option number 3 is the correct option. Last question we have came into the correct statement regarding the carbonyl compound with the hydrogen atom on its alpha carbon. So for this what happens, you can read the incorrect statement as well, but I am telling you the correct answer now. So the correct answer here is keto-enol tautomerism is possible only in those aldehyde and ketones that have at least one alpha hydrogen. Okay, this is reasonable because for for keto-enol tautomerism, presence of alpha hydrogen is necessary. Okay, alpha hydrogen has to be there, which can convert the ketonic group to an enolic group. So option number 4. carbonyl group with a hydrogen atom and on its alpha carbon equilibrates corresponding enol to the process known as ketoenol proteomerism. Okay, hydrogen alpha hydrogen is present, so ketoenol proteomerism can take place, and it is present in equilibrium with each other. Okay. Okay. So thank you so much, students.